I guess we could also prepare. Oh, I didn't prepare. Date modified. Download. All right, I also want to throw this out there. I want to go deep research, and then I want to say, I want to know, what do I want to know? The relevant hormones / neuromodulators involved in attention, focus, and motivation. Right. That's it. What else would we want to know? And reward. And achievement / award. Award? Reward? Yeah, let's run it. Okay, we've got our book. I think it's here, right? Can we open this bad boy up? So I think we have this as like a contingency plan. We don't have to go into this unless we have time and we want to. What do we have? We got identify the primary neurotransmitters and hormones associated with executive functions, specifically focusing on dopamine, norepinephrine, serotonin, acetylcholine, and cortisol. Research the specific role of dopaminergic systems in the mechanics of motivation, reward, prediction error, and the subjective feeling of achievement. Investigate the functions of norepinephrine and acetylcholine in regulating arousal, alertness, sustained attention, and the ability to filter out distractions. Analyze the influence of serotonin on mood regulation, impulse control, and patience, specifically how it modulates the pursuit of long-term goals versus immediate rewards. Nice. Okay, examine the effects of endocrine hormones such as testosterone, cortisol, and adrenaline on drive, competitive behavior, and the maintenance of focus under stress. And then synthesize. Okay. We're missing like what is it? It's like, okay, oxytocin versus and vasopressin. We're only we're missing a I'm gonna say this so I don't bias it towards what it would talk about. And then hopefully that just adds to it. Oh, I just literally dropped the folder. Okay. And then let's do a little bit of that action. And we are back. We're back to our favorite book on embodied cognition. Everyone loves this book. All the viewers love this book. Just ask them. We're all the way at. So we had. Okay, well, we've talked about stuff like this, right? Inactive vision. Yep. Language. What do we do? We didn't talk about any of this stuff. Reasoning and education. We did what did we do? No. We didn't even do this, right? Virtual reality, definitely not. Social and moral cognition and emotion. We did this stuff, right? We did embody. We might have done this. I think we did mind shaping. Yeah, mind shaping was the one I really liked. The embodiment of culture. I don't know. Blah, 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 blah. We did morality in the body. That was a huge one. Embodied emotion concepts. Memory and action. Motor resonance. The embodiment of attention. Blah, 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 blah. Embodied remembering. Yeah, we could do that stuff, but I think what I'm here for... Oh, was there not like an embodied attention? I could have sworn there was embodied attention. Oh! Was it this? The embodiment of attention in the perception action loop. Ooh. Okay, let's just see what I've done here. Okay. All right, so that one. Oh, that one as well. It's got goodies. And then this was the attention and okay. Well, maybe we do them all. I don't know. Let's see where it takes us. It was starting at this one, maybe? Memory and action? Action, memory. I just don't recall if... Can I get this more granular? This is probably fine. I just don't recall if we've read this already, but I think I would remember. Let's make sure that this guy gets going. Identify the primary neurotransmitters and hormones associated with executive functions and motivation, specifically focusing on dopamine, norepinephrine, serotonin, acetylcholine, cortisol, oxytocin, and vasopressin. Let's get a second Gemini going and say, what are these the main neurotransmitters, hormones / neurotransmitters involved in attention, focus, motivation, reward? And if it actually, you know, I should have just let that go. Redo. Yeah. And if it tells us anything else, then we could add it to the other one. The first publications in this emerging field address the question of how language processing is grounded in action and perception. These studies suggested that there are interactions between language and perception and action. Over the years, convergent evidence on these mutual interactions of action and perception with cognitive processes have given rise to an extensive line of research that explores ways in which different domains of cognition are grounded in various action and perception patterns. All right. The chapter begins with a discussion of relevant insights on memory systems and the role of the body in cognitive processes. This is followed by a more in-depth discussion of empirical research that relates to the memory and action theme in different domains. The chapter continues with an exploration of new directions in memory and action research, specifically in clinical psychology, and concludes with some purported limitations of the embodied cognition approach. Okay. We got gray. So gray, weirdly enough, I switched it out with the most recent stuff I've read, but gray is important, extra important. Yellow's like stuff that I'm trying to, you know, make sure I see again, but gray is like important stuff. So converge on the idea that memory processes has specific neural underpinnings. Rubin considers episodic memory to be a collection of interacting basic systems, including vision, emotion, language, search and retrieval, explicit memory, narrative, and motor systems in which each basic system has its own neural substrate. Okay, we actually gotta steal this stuff. We gotta gank it. Part one, to do. When we talk about memory, we should be talking about this type of, we should be at this in depth, I think. Where do we got? Memory, pattern recognition. Actually, I could just do this. I could say, grab notes from the Routledge Handbook of Embodied Cognition, Chapter 35, Memory and Action. Beautiful. Now we don't have to do anything. We can just chill and read. Okay. For example, the neural substrate of the search and retrieval system is in the frontal lobes, whereas the hippocampus and surrounding structures are relevant for binding aspects of memory. The notion of a neural basis of the basic systems is supported by research showing activation of specific brain areas while retrieving an autobiographical memory. At the start of the retrieval process, activation of the areas associated with explicit memory and search and retrieval increases, whereas activity in the visual cortex reflects the re-experience or maintenance of an event once it is retrieved. Okay. So they've found specific processes that they are interpreting as search and retrieval, and then there's this actual replaying of the experience, which would take place in many areas, but including the visual cortex. The visual cortex reflects the re-experience or maintenance of an event once it is retrieved. This corresponds to increases in amygdala activation and higher subjective ratings of reliving the event during the retrieval process. Yep. These interacting brain systems associated with memory retrieval processes illustrate the grounding of cognition. In other words, the experience of an event and the reconstruction of an event when it is being retrieved occur in a similar way, and with the same brain activation and the same systems involved as during the original experience. That's the big ticket item here. This is the one that should be like a different color than all the other ones. I mean, we talk about that all the time, but it's just cool to see someone else, read it or write it. This description is consistent with Damasio's theory of the neural architecture underlying recall and recognition, in which activity occurs in multiple brain areas near the sensory portals and motor output regions. Thus, instead of a single place for the integration of sensory and motor processes, multiple sites exist that are also recursive and iterative. The integration occurs in convergence. Okay. How much do we want to go on this? I feel like we don't need to do memory stuff right now, so I might skip this chapter, and then let's just see what was in the next chapter, and then I think we're really trying to get to that attention one. One of the most convincing results in support of embodied cognition is the evidence that when we observe another person performing an action, our sensory motor system is activated up to the muscular level as if we were performing that same action. Taking its cue from physical acoustics, this phenomenon has been named motor resonance. Okay, this is stuff that's pretty neat. This just supports this view that we are constantly simulating, let's just say, parts of the brain, even when we're not actually doing the activity that would usually activate those parts of the brain. So that's why it's called simulation. So I keep bringing up this idea that when we think about the concept of kicking, parts of our brain are simulating the areas that would usually be involved when we're actually kicking, but there's inhibition on the end point where that would actually tell your muscles to kick. So it's primed to kick, but it's not actually carrying out the motor movements. All right. Similarly, numerous studies have demonstrated that motor resonance allows I don't know what this word is. Somatotopic principles and happens in a muscle-specific manner. Given that this automatically induced sensory motor representation of the perceived action corresponds to what is spontaneously generated during actual action execution, the outcome of which would be known to the agent, embodied theories of cognition suggest that this motor replica may support action perception and understanding. Research described in this chapter shows how the clamp-like top-down influence of actor and observer intentions, values, and attitudes can affect motor resonance. All right, so we really don't care about that right now, even though that's really cool. Unless maybe we see a gray. Do we have a gray? This chapter is attempted to explain the neurophysiological roots of motor resonance and to present evidence that its function in understanding and anticipating the actions of others requires sharing goals with them. Without this sharing, the motor resonance and perhaps a true understanding of the intentions behind others' behaviors are absent. Furthermore, okay, so this chapter was actually really cool. Now that I'm reading this, but we're not gonna go into it right now. Furthermore, there is evidence that sharing the immediate goal of an action is insufficient to produce motor resonance, and that it is also necessary to share the motivational, moral, and social aspects that lead to its performance. So we could read this one actually. What chapter would this be? 36? We can read chapter 36 whenever we do social stuff. So, social environment. October. Read chapter 36 of Embodied Cognition Handbook. Okay, but now onto the main event for the stream, at least what I named it. Let's check on this. All right. Yes, your list is mostly correct, but it mixes general cognitive drivers with very specific social drivers. To give you the most accurate picture, we should separate them into two groups: the core engines, essential for any task, and the social specific modulators, essential for social bonding and stress management. Okay, here's a breakdown of your list, along with a few missing key players. These are the primary chemicals that drive your ability to get things done. We got dopamine in here, motivation and reward. It's the main driver of a motivation and reward, but it's not reward in the sense of that satisfactory feeling of achievement. It's the feeling of reaching the reward and all that would give. It is not just about pleasure, it's about craving and pursuit. It tells your brain this is important, go get it. It is crucial for starting tasks. All right, then we got norepinephrine, the fuel, also known as noradrenaline. This governs alertness, arousal, and energy. It mobilizes your brain and body for action. If dopamine is the steer, norepinephrine is the gas pedal. So, okay. Acetylcholine, this is critical for sustained focus and learning. It acts like a spotlight in the brain, amplifying the signals you want to focus on while quieting the background noise. You need this to, okay. I at this point, I want the slightly under functional level discussion where I want to know exactly how this is driving whatever it is, glutamate or whatnot, or in this case, glucose. Serotonin, while often associated with mood, in this context, it regulates impulse control and patience. It helps you resist distractions and immediate gratification. Okay. The context chemicals, stress and social, these affect focus and motivation, but are situational. Cortisol is the stress hormone. Consistent, high level. Okay. These are social hormones. They are involved in social bonding. They are not primary drivers of abstract focus. However, they are heavily involved in social motivation. All right, here we go. The two major neurotransmitters that are arguably the most important for general brain function. Glutamate, brain's primary excitatory neurotransmitter. It is essential for learning and memory formation. Without it, the brain essentially turns off. And then GABA, the brain's primary inhibitory neurotransmitter. It calms the brain down. For focus, GABA is vital because it shuts up the neurons that are firing unnecessarily, allowing the important signal to get through. Okay, let's restart on this then. Let's get let's start with dopamine, norepinephrine, acetylcholine, serotonin, glutamate, GABA, and then perhaps the actual reward molecules, for example, oxytocin. I want to know how these actually interact with each other and how they affect the deployment of attention, focus, motivation, glucose, etc. Okay, let's give it that now. Did I spell them all right? Oh, I forgot cortisol. Ew. Can we get that in there, actually? Yeah, let's get that in there. Let's do it. Let's do it right. All right, the embodiment of attention in the perception action loop. This chapter describes a series of examples of where the computer metaphor of the mind breaks down, with a special emphasis on attention, and points to an embodied and situated account of mind that can naturally accommodate those problematic phenomena that undermine the computer metaphor. Dynamical systems theory. All right, rather than proposing the next new metaphor for the mind, we instead encourage drawing eclectic inspiration from embodied cognition to appreciate how the body itself performs some cognitive operations. They pull from ecological psychology to appreciate how the relation between organism and environment produces cognition, and dynamical systems theory to carry out analog information processing simulations, and cognitive neuroscience to stay grounded with the real physical material that lies at the hub of cognitive phenomena. All right, a number of findings pose problems for the model. Okay, I don't know what model we're posing problems for, but some conjunctions of certain types of features appear to elicit parallel search processing rather than serial. Continuous gradations in similarity between a target and its distractors account for reaction time patterns better than treating visual features as discretely belonging to one feature map or another. Analysis of a million trials across dozens of visual search experiments reveal no evidence for one population of serial search phenomena and separate population of parallel search phenomena. What are we even talking about? If the target can only be identified by a conjunction of two features, say red and vertical, then the redness feature map and the verticalness feature map will each have multiple regions of activation on them, making pre-attentive identification of the lone target impossible. All right. And when the visual display spends its first 100 milliseconds configured with a single feature distinguishing the target before then converting to a conjunction of features, one sees neither a parallel search nor a serial search, but something clearly in between. These types of findings all led to treating visual search as belonging on a continuum of efficiency rather than being implemented by either a pre-attentive parallel filtering mechanism or an attentive serial filtering mechanism. As the passive feed-forward filter approach to visual attention failed to account for new findings, it made room for a more proactive, goal-oriented approach to attention, rather than the emphasis being... So I think there was this heavily perception-oriented notion of attention that we're specifically moving like a spotlight around and we're seeing what's inside the spotlight. This is now, pointing out the change towards a more robust view of a much more active form of attention, goal-oriented as well. All right, rather than the emphasis being on how perceptual systems convert stimuli into interpretations, a new emphasis was building on how attention results from motor systems making real-time demands on what sensory input is needed or expected next. So this is active inference in its finest. Or it's like literally active inference by definition, almost. Okay, let's check on this. What do we got? Investigate the specific physiological roles of dopamine, norepinephrine, and acetylcholine in the regulation of executive function, specifically attention spotlighting, focus, duration, and goal-directed motivation. Hell yeah. Research the excitatory and inhibitory mechanisms of glutamate and GABA within the prefrontal cortex and how they establish the signal-to-noise ratio necessary for deep concentration. Analyze the functional interactions and feedback loops between the pursuit neuromodulators, dopamine, norepinephrine, and the satiety reward neuromodulators, serotonin, oxytocin, focusing on antagonistic or synergistic effects. Examine the metabolic pathways connecting stress hormones, cortisol, epinephrine, and neuromodulators to glucose mobilization. Specifically, how they regulate energy availability for the brain during high-demand cognitive tasks. Explore the effects of acute versus chronic cortisol exposure on the reception and synthesis of dopamine and serotonin, and how this alters motivation and focus. Okay. Synthesize information regarding the Huberman style. What? How did Andrew Huberman get in here? See that big right now? Or general neurobiological models of how these chemicals sequence together to transition the brain from a state of alertness, stress, to action, and finally to reward/recovery. Let's get going. Let's start it up. Okay. What do we have? We have interactive models of attention. This more proactive approach to attention raises the question: where in this goal-oriented account of attention do the goals come from? They proposed a neurally inspired account of visual attention in which neural representations of objects, in other words, Hebbian cell assemblies or population codes, compete against one another in parallel for the privilege of eliciting their associated motor output, such as an eye movement or a reaching movement. So this is kind of a global workspace theory idea, except that we're not talking about consciousness here. We're talking about how the competition is for broadcast, but not necessarily for conscious broadcast, even though it ends up being conscious broadcast. Consciousness is just a manifestation of this broadcast system, but the broadcast system is much more fundamental. And this broadcast system allows this signal to reach other parts of the brain, which allows further propagation. That's the whole idea of complexity and integration. The information actually propagating across the entire network. Okay, neural feedback projections from frontal brain regions to visual brain regions can then bias this competition process based on goals and other information from other sensory sources. So this is literally this is once again a predictive processing view of how the selection process happens. It's heavily affected by priors. This biased competition account of attention has been extremely influential and naturally makes a number of empirical predictions that have indeed been reported in the experimental literature. For example, when a visual stimulus is especially relevant for the goals of a visuomotor task, single cell recording in monkeys show that neurons responsive to that stimulus exhibit a higher firing rate than when that same visual stimulus is presented to that receptive field but is irrelevant to the task. So rather than thinking about like there being a task and now you're filtering something differently because the task, your brain is expecting something related to what you're trying to do, and therefore it can obviously affect this type of difference of activation. Moreover, fMRI results with humans showing that when a tactile pre-cue is spatially congruent with a visual stimulus, activation in visual cortex for that visual stimulus is greater than when the tactile pre-cue is spatially incongruent. I don't know quite what that means. Visual input of a face can trick the process of speech recognition into perceiving a spoken syllable one way or another. Auditory input this is another sense where you would imagine that visual input has the visual input has now affected your priors in some sort. That's now why did I do that? Why am I clicking around like this? I don't think there's an easy way to get back. Oh man, Daniel N, what's good? Stanistupration, Stanistupration, the manistupration. I don't even know if either of those are words. Yo, Darmadam, what up? Don't look that up, by the way. Oh no, is it an adult word? All right, well, where are we going? We have to find our way back to chapter 37. I have to stop clicking around. Okay, and spoken linguistic input can make a conjunction search process function as though function as though it were a parallel process uninfluenced by the number of distractors. Okay, I don't know what that means either. In sharp contrast to Fodor's proposal of sensory systems as informationally encapsulated modules, these kinds of findings support a radically interactive and distributed account of attention where even purportedly unimodal perceptual systems are being biased by other modalities. So, yeah, it's not just the case that our eyes are just like scanning like visual input and we're taking it in and we're just putting it through this filter. It's that everything about what we believe that we're seeing right now is being first pre-biased by these top-down predictive priors. What are we reading today? We are reading the Embodied Cognition Handbook chapter on attention, and actually we're just doing the one on attention. I decided that maybe the memory one is a little too similar to stuff we've already talked about over and over again. But just more from this book. I heard something interesting about visual perception. Let it rip. Yeah. And then if we get through this stuff, and this should be a little more accessible and fun, we'll get to some nitty-gritty research that I'm having this thing do specifically on the hormones and neurotransmitters like involved in attention and motivation and focus. So we get the whole Huberman-esque story about dopamine and acetylcholine and stuff like that. Okay, cascaded models of attention. Even if every subsystem is influencing practically every other subsystem, this leaves open the question of how immediately those influences are transmitted. Traditional stage-based accounts of processing function by having each stage complete its operations before then passing out an output to the next stage. This is quite different. So yeah, traditional stage-based accounts, you do that. It's like multiple filters. It's like put all these filters through, or put whatever input, whatever perceptive input, sense data, whatever it is, just put it through a bunch of filters. But this is quite different from a type of system that functions on partial, fuzzy, incomplete, and distributed information that is constantly in flux, which is really what our brain's doing. It may feel counterintuitive to think of attention as something this diffuse and partial, rather than it being narrow and directed. But many studies have shown that we operate as best we can with a constant flow of partial bits and pieces of information. Okay. Over the course of a few hundred milliseconds, the continuous accrual of perceptual information in visual brain areas was constantly cascading into oculomotor brain areas to contribute to the gradual development of an eye movement command. That's how pervasive this idea of I don't know, the global network and competing drives. You could consider that. And this is all leading to this gradual development of an eye movement command. Okay. There's this practice, fire kasana, where you stare at a candle, then watch the after images, and the progressive visuals are meant to mirror some layered perception of the visual process. Interesting. You could see a colored ball that rotates around, then geometry comes off it, then archetypal imagery, things like that. That's cool. As the stages peak of it, your vision is meant to be completely malleable to whatever you want. Oh, I see. I see. At the peak, okay. At the peak of this thing, you can pretty much direct it in whatever direction you want. But then I also imagine you could do some sort of like mindfulness meditation here, where you're just seeing where it goes without trying to move it anywhere. That is pretty cool, though. Is staring at fire in any way bad for you? Because that could be fun to try. All right, when microstimulation then triggered the evoked saccade in a neutral direction, some portion of that still developing voluntary response was also active in the frontal EF. What is the FEF again? The frontal eye fields, of course. All right, the resulting movement was a weighted average of the evoked neutral saccade and the partially accrued command for the voluntary response saccade. Clearly, the motor system is not patiently waiting to be delivered a completed command from the cognitive system, but is instead continuously participating in the development of the understanding of what a stimulus means for that organism, thus blurring the line between what is motor and what is cognitive. All right. This kind of partial processing can be found in many decision-making tasks where information can cascade through the system even without subjective awareness. Of course, a lot of this is happening without subjective awareness. Okay, they trained participants to rapidly identify whether an animal or means of transportation was present in a picture displayed for a mere 20 milliseconds on the screen and then masked. Animal and transportation trials occurred in separate blocks, and responses were made via a go, no-go paradigm. So we still have to go into this no-go, no-go idea. Participants were extremely accurate in this task in identifying whether those objects were present or not. An initial interpretation of this result might be that in a mere 20 milliseconds of input, the feed-forward sweep of sensory information appears to be enough to carry out visual object identification in a seemingly context-free manner before frontal brain regions would have time to respond and send feedback to visual areas. Okay. Ancient thing to stare at fire. Absolutely. Yeah, I'd imagine that it wouldn't be that bad for you. Unless staring at the sun, you'll be all good. Right. Daniel Ingram is the guy for fire, Kasana. He is also cool in general. He's an MD. Oh, that's awesome. Maybe we got to get a candle one of these days going and just stare at it. I could put it right here and we could just all stare at it together. I could set up the camera. Okay, so yeah, participants were quite accurate when they were only given 20 milliseconds to identify whether an animal or means of transportation was present in the picture. However, this neglects the fact that the task of identifying a pre-specified object's presence or absence is itself a goal-oriented task. Goals are driven by frontal and prefrontal cortex, which has feedback connections to visual cortex. What is likely happening in this scenario then is not a context-free feed-forward sweep whereby some particular category is rapidly identified, but rather the goal of looking for this target even before a stimulus is presented involves feedback signals from the frontal regions tuning those visual receptive fields to temporarily become car detectors or animal detectors, focusing processing on features that are associated with those categories. What then directs where attention goes if it works in this radically distributed interactive fashion? If we have a system that cascades its information from subsystem to subsystem so promiscuously that we lose track of which signals are feed forward and which are feedback, can we still have something coherent enough to be called attention? Rather than conceiving of attention as a spotlight directed by a central executive, a more scientifically sound approach may be to conceive of attention as the emergent result of biased competition among multiple partially active representations. This is exactly what we got with the global workspace theory when we were looking into consciousness. Rather than assuming that the focus of mental activity at any one point in time somehow derives from one source, like the central processing unit of a computer, perhaps it instead derives from myriad sources. Some of these sources are goals and biases from neighboring neural subsystems. Some of them are biases from immediately perceivable environmental constraints. Some of them are biases from signals delivered by other people in the environment. At longer timescales, some of these biases are social norms and cultural constraints. At even longer timescales, some of these sources are evolutionary influences. The density of perceptual acuity at a particular moment in time, the sense of who we are and what we're about at that moment, is something that emerges non-linearly out of the complex interactions among innumerable informational biases competing and cooperating in real time. All right, this is nothing new to what I usually speak about, but it's still really cool to hear someone say it. Okay, can I copy this? Can I gank it? And then can I get this in? We just need this in the part 2 notes. This needs to be noted in the scope of attention here. Deliver our conscious grasp of attention. Oh, I think this is it. Our conscious grasp of attention, maybe. Yeah, this is the type of story we're trying to tell here. Oh, that looks fine. Wow. Okay, that was a good paste. Very nice. Embodied cognition handbook. Chapter on attention. Maybe 37. I forget. I don't remember. Yo, Onion Humming. A bunch of people stared at the sun in Portugal in 1917 and ended up saying they saw the Virgin Mary. So this is actually this is a great example. So the idea would be that if they had not known about the Virgin Mary and there was no archetypal symbol of the Virgin Mary within whatever spiritual foundations they teach in that culture, then they would not have seen the Virgin Mary. It required that those priors to bias what they saw, who apparently visited 3 children and told them a whole bunch of prophecies. That's pretty cool. Now, granted, obviously, like the Virgin Mary is a pretty abstract category and probably shows up in a ton of cultures, so you could probably see that or you could probably have, cross-cultural stories of seeing, some deity like that in the sky. It's also said to be one of, if not the best technique for concentration, but it is volatile. That's why I don't do it anymore. Ooh, what is it being volatile mean? So I would imagine that it's actually quite I don't want to say easy in a sense, but it's engaging in a sense that like fire is just constant novelty. So unlike mindfulness meditation, I feel like you do get to a point where you feel the same way. It's just constant novelty. Now, granted, when you start out mindfulness meditation, I bet mindfulness meditation is much more difficult and seemingly much more boring than, let's just say, looking at a fire. That said, yeah, I bet you arrive at a similar place where both would be quite stimulating in some sense. Okay, I would randomly see a colored circle in the middle of my vision when not practicing. Oh, I see. So it has long-term effects. Jeez. That's strong evidence of why you shouldn't stare at the sun. So I felt I couldn't control it in a sense and stopped. I mean, yeah, either like that, or you literally built something that you know, I always say built something as if you've built those connections that are now making you expect that signal in your attention, in your vision, and so then it shows up, even though there's nothing that should be making that, right? Daniel End, or if you're Catholic, why you should trust Marian apparitions. Did you see what Jung said about UFOs? No, I did not. Maybe there was more nuance, but something like our environment and media is more techy, so we evolved from magical myths into tech myths, and as we looked to the stars, we projected that onto UFO myth. Great theory. Sounds good to me. Interestingly, I've never heard of any non-Christians say they've seen the Virgin Mary. It's always Christians, especially Catholics. Right? That's both interestingly and also almost obviously. To be fair, I don't know if I've ever seen the Virgin Mary. I don't know what she looks like. True. You're about to be called a Protestant by the Catholics. Uh-oh. We having a religious war in the community here. All right, so we got that. I think we're all good. Cascaded interaction spreads with different sensory, cognitive, and motor systems continuously biasing one another in real time. There is no point in time during which a given subsystem is processing its input in a context-free manner. Right, if everyone's plugged into the global workspace, there's no context-free processing. Everyone's already biased by other information that's already in that global broadcast. There will always have been some form of contextual bias that was busy influencing the given subsystem immediately before some new afferent sensory input enters it. If continuous distributed interactions between sensory systems make vision no longer an encapsulated module, and audition no longer an encapsulated module, is this how you use audition to describe like audio or audio signals? Audition no longer an encapsulated module, then continuous distributed interactions among cognitive processes and motor processes make cognition no longer a module that is separate from action, hence embodied cognition. In fact, given the millisecond timescale at which various motor movements continuously update the sensory input, which continuously updates cognitive processes, which continuously update the ongoing motor commands, perhaps these external actions themselves may not even be informationally encapsulated from cognition. All right. This like lends itself to the idea that like our movements, both at the level, like the intuitive level of our attention, as well as the level of our motor movements, is a means of thinking in some sense. Like these processes are all involved, and I guess how do we make this intuitive? Like obviously when people talk, they use their hand movements, and that helps themselves. Not only it's not just for communication, but it helps themselves like get in the spirit in some sense. And then what else? Like what I'm doing right now, where I looked up to think about this thing, or I looked to the side to think about something. You know, you can imagine that attention shift is actually helping me in some sense. I'm looking to something maybe that's really boring. Maybe that's why. Maybe it's like as long as I look away, like you see this when people are talking to each other, especially if I feel like this is even more so the case when you're introverted, and you know you might get a lot of not necessarily stress, but it's very cognitively demanding to have to deal with social norms in the moment, right? Like you have to you have to be on when you're when you're looking at someone. You have to take in all these signals. So when you're trying to think about what you're trying to say, maybe it's good to look away at something that isn't that stimulating, especially not as stimulating as a person, another person's face, and then that allows you to think about the thing. Then you obviously want to look back to make sure that you get the feedback. But that's the type of way we can think about this. Okay, that's my guess, by the way. But I'd imagine we could figure that one out. Okay, I'm always up for inciting cross-denominational riots. Hell yeah. She is full of grace. That's all you need to know. True. I think I may have seen her then. This is a hilarious comment. Thank you, bro. I'm always up for a site. Yeah. Martin Luther. If you got a printing press, you better. Like the heady combos with no eye contact. Yep. Is that not what we're doing right now? This is why we're optimally thinking right now. We don't have to deal with each other's facial feedback in some sense. Because yeah, it's not just you're not just getting signals from them. It's like when I guess, yeah, I don't know. Is it what would happen when you're looking at someone who's looking at you? Just more self consciousness, like needing to react in certain ways. I'm not sure. Okay. I do want to kind of steal some of this too. Because I think this is an important thing to note as well when we're talking about attention. Okay. Okay. Skeletal motor movements are a useful way to perform cognitive operations, such as pressing keys on an interactive computer interface. But there is a far more ubiquitous motor movement happening about 3 times per second that performs cognitive operations during your entire waking life, no matter where you are or what you're doing. Eye movement. These people demonstrated that a given eye fixation can function like a pointer in a content addressable computer memory. Oh, okay. A pointer, as in like you might have heard of the idea of like pass by value versus pass by reference. It points to where the actual value is. It's basically like a memory address. That's what the pointer is. So rather than forming neural representations of complex visual objects in memory while viewing a scene, people often simply maintain spatial locations in memory and send the eyes to those locations to access the content in those addresses. Whoa, okay, is that what we're doing when we look away? What is going on here? Essentially, people exhibit a stronger tendency to use one's environment as an external memory store. Okay. Wow, that's incredible. So yeah, you could think of it like the pointer, but you're also thinking of it. You could also think of it like using some motor movement as a stimulus to find the thing that's associated with that stimulus. And so then you also need to know what stimulus would cause this, you'd have to have something that tells you what the eye location would be that would tell you about this other. So it's like pointers of pointers of pointers. This is like, maps of maps of maps. Okay. Thus, on the time scale of a few hundred milliseconds, eye movements are changing how the environment impacts your sensors, which changes how you cognize your environment, which changes the next eye movement, which changes the next sensory input, and so on. This is a recurrent causal loop that cannot be unraveled to find the chicken versus the egg. Half of the data transformations that constitute an organism's attention are actually happening outside the body, and how the body's movements have altered how light projects onto the retinas. So much so that one could be tempted to suggest that much of your visual experience is itself happening in the space around you rather than solely inside your brain. Right, but now we're just getting into semantics about, like, you know, what does it mean to, like, extended cognition versus whatnot. I don't know if that's a super helpful thing to discuss. Okay, what are we talking about here? Eye movements in the perception action loop. In this way, not only are eye movements highly useful for the experimenter as a record of what is drawing attention at any moment, but they are also highly useful for the organism itself. A different pattern of eye movements on the same scene will not only reveal different thought processes about the environment, it can cause a different thought process about the environment. For example, just as recording eye movements during mechanical problem solving has provided a deeper understanding of mechanical reasoning, it has also provided inspiration for improvements of training with technical devices. Even high-level conceptual insights can be jump-started or missed entirely by different eye movement patterns on a diagram associated with an insight problem. People who are 30 seconds away from solving a diagram-based version of Dunker's famous tumor and lasers radiation problem. Oh, that's what was discussed up here, actually. Tend to make a characteristic pattern of eye movements on the diagram. Those who are 30 seconds away from giving up on the problem exhibit less of that eye movement pattern. Interestingly, this pattern of eye movements was not merely an indicator to the experimenters that a person was about to solve the problem, but that pattern of eye movements was actually assisting the person in arriving at the solution. In their second experiment, Grant and Spivey subtly animated the diagram in a way that unconsciously induced that pattern of eye movements, and it doubled the proportion of people solving the problem. Wow. Okay. Guys, they removed Podfriend. Literally 1984. His only trace is on the screen on this stream. Potfriend. RIP. Oh no, this is a compelling reason why we should become affiliate, just so we can get Podfriend back. What's more important, ads or Podfriend? All right, the embodiment of attention. Okay, so this is the summary, so we can just read it all. Cognitive science has a long history of drawing inspiration from the computer metaphor of the mind and placing the bulk of its emphasis on how external stimuli influence mental processing. But this is only one half of the story. The other half, of equal importance, is how mental processing influences external stimuli. When attention gets physically embodied in motor movements, even subtle and brief ones like eye movements and other muscle twitches, those movements change the way the environment impacts our sensors in ways that abide by continuous physical laws. That's a steal. Let's just do this so I keep track of them. The result is that while the environment is catalyzing events in the brain is simultaneously catalyzing events in the environment. Motor movements, for example. I don't think that would just be the example. I think that's what it means. Any type of motor movement, though. This autocatalytic loop, where the brain and the environment produce an emergent phenomenon called cognition, steers our understanding of the mind away from the formal logical computer metaphor, where genuine autocatalysis is not logically possible, and it is radically changing how we conceptualize joint action when two people are sharing an environment and intermingling their perception-action loops. That was discussed in the previous chapter, but we'll do that when we go into the topic of social dynamics. If we acknowledge that attention in particular and the mind in general is an emergent property of an embodied brain interacting with its environment, then the future of cognitive science will require a complex dynamical systems approach to cognition, drawing insights from embodied cognition, ecological psychology, complexity theory, computational neuroscience, and robotics. All right. All right. Embodied remembering. What do we got here? Just as the dynamic on-the-fly embodied production of another successful backhand in tennis brings about a shot that may be familiar in type, but is absolutely new in detail, so in remembering events, my changing beliefs, interests, and motivations select and filter out materials to construct versions of the past. Okay, this is just talking about reconstruction and memory. All right, I think we're gonna chill now on that, right? At some point, we got to read the replication crisis in embodied cognition research. Did I don't think I had highlighted anything here, because this was all new. But I don't think we're doing that today. We got to learn about some chemicals now. Okay. 7TV works for non-affiliates too, I think. Anyone correct me? Yes. Yo, Heradev, what's good? Heradev. How do we get 7TV? Is that something I can install via either Streamlabs or Twitch itself? Okay, so the next topic here, the neurochemical economy of high performance and integrative analysis of neuromodulatory interactions in attention, motivation, and achievement. All right, this is the most boring we'll ever get about this topic, so that I can make this topic less boring. But I need to have this type of background information before we can start figuring out how we want to tell the story of attention in a accessible way. I mean, a lot of this stuff is intuitive. Like people understand dopamine and how that affects your, TikTok scrolling and whatnot. But installing 7TV involves three main parts: setting it up on your browser so you could see them, adding the emotes to your channel so they exist, and setting up your streaming software so they appear on your stream overlay. Oh, so it requires a stream overlay. So it doesn't actually affect the chat in Twitch chat, right? Is that what this is saying? If I am not affiliate and I don't display chat on the screen, but instead I just have the normal Twitch chat, then does 7TV not allow me to... it's been a while, but I believe you go to the 7TV website, sign in with Twitch login, add emotes to your channel. Oh, okay. That's what it's saying when it says add emotes, so it has nothing to do with affiliate here. Then everyone with the browser plugin can see them. The next step to add the browser plugin is just if you want yourself to see them. Oh, okay. So, I just want to add more emotes to my Twitch chat, not displayed on the stream. Would I do, should I do 7TV or Better Twitch TV? Not 7TV. That was released in about 2020 or so. Abstain is definitely going to spend like 3 hours on that emotes page. Uh-oh. Can I just add as many as I want? I think you can add example onion as a mod on 7TV and he can add emotes too. Nice. Is there a pool from which you add, or can you create your own? Okay, adding as many emotes as possible without worrying about complex stream overlays. You should choose 7TV. The difference is the number of free emotes. 7TV gives you 200 free emote slots immediately. You can add hundreds of memes, automated emotes, and inside jokes. Better Twitch TV gives you only 15 shared plus 15 channel slots for free. You have to pay a monthly subscription to get more. All right, we sign in on Twitch. We create an emote set, stuff it full of emotes. Make sure that emote set is linked to your Twitch channel in the 7TV dashboard. Crucial note for your chat, you and your viewers will not see these emotes unless you have a browser extension installed. Okay. Hot dog has like 300 free slots. Both, I believe, limited amount of uploads perhaps used to be. So then what happens though once we do get affiliate? Do we just choose our favorites to be the official emotes that everyone sees? Is that how that works? And is there a more lenient policy on like copyright pictures when you're using 7TV? Should I just choose my favorites from the 7TV pool to become official emotes that everyone sees? And is there a more lenient policy on 7TV emotes such that I could use copyright images there? On 7TV, no one cares. Twitch emotes are manually verified, I believe, unlike 7TV. Yeah. Okay. All right. A common point of confusion for new streamers. The short answer is no. You generally cannot and should not move your favorite 7TV emotes to your official affiliate slots. Okay. Here's a breakdown of why and how to handle the copyright policy differences between the two. So can I make 7TV emotes official affiliate emotes? No. Twitch's subscriber emotes, the one you unlock at affiliate, have much stricter rules than 7TV. Twitch requires that you own the rights to every single pixel of a subscriber emote. You cannot take a popular emote like CatJam, KekW, or Pepe from 7TV and upload it as a sub emote. Twitch will likely reject it during the review process or remove it later because you didn't create it. Artist permissions. Even if an emote is free to use on 7TV, that usually means free to use on 7TV, not free to monetize as a benefit for your subscribers. Oh, you monetize emotes with affiliate? Are affiliate emotes monetized? What's up with that? Okay. Is 7TV more... okay, yes, significantly. The Wild West of 7TV is where everyone puts copyrighted material. This is where you can find SpongeBob, anime characters, movie scenes, and famous memes. While 7TV technically has rules against copyright infringement, in practice it is rarely enforced unless the copyright holder complains. Twitch scans official emotes heavily. Okay. Not exactly. You do not get paid a royalty every time someone uses your emote. You don't earn that. However, in the eyes of the law and Twitch, they are considered a monetized commercial product. The paywall concept. While you don't get paid per use, the emotes are part of a package you are selling. Oh, you can only use it if you subscribe. Okay. What's going on over here? What is happening here? We've got 7TV emotes. We got Feels Pumpkin, man. What is going on there? Oh, I'm seeing that through Better TV, Better TTV. Global emotes. Do this IRL. Do what IRL? Get a pumpkin and put my head in it? Oh, nice. You can give artists shoutouts too with Twitch. For example, if you click this, it should both say which channel it's from, plus the artist that made it. Oh, I see. Okay, so if I were to click that, I see Daniel52 Heart Love, follower emote, Daniel and artist. What am I seeing? Oh, this is their Twitch channel, and then there's two links here. I don't know what. Maybe the artist has an emote next to their name as their artist name. Very cool. Okay. Well, we're gonna have, you know, the criteria for an affiliate emote's gonna have to be pretty high here. I'm gonna have a pretty high bar for these emotes. That being said, I gotta start thinking about 7TV emotes that we could do. There's one, so instead of maybe like a Feels Bad Man or a Feels Pumpkin Man, I think I'm gonna go with one that we had on our Discord. There's this whole thing about the Sneetches, which is actually just like a story about racism. Honestly, it's like the people with the star bellies were like royalty, and anyone without a star belly was. It's either that or the other way around. I think it was the star belly people are extra. Yeah, they're extra snooty. But there's this one image of a sad Sneetch that we have as Snadge, and I think that is hilarious. Can I find the Snadge? Where's the sad Sneetch? Sad Sneetch. That's not it. Oh, this is it. This is the one. Just this guy's head. This guy. Oh, I don't know where we're going here. Can we get the image? Yeah, just this guy's head as Snadge. I think is so funny. I don't know if anyone else has done that, but we have that in our Discord, and it's just hilarious. This is just a crazy book. All right, what are we seeing here? More. Oh, we got kiwis. I feel like we do a better kiwi. This looks like a stuffed kiwi. We got to get a penguin though. Oh, we got a penguin. Yo, what is happening? Yo! Jesus. I don't even know if this makes sense. This is actually a good question. If that guy was still underwater, how far underwater would he have to be before this wouldn't actually hurt him? An explosion at surface level. Like the water, I imagine, just takes a lot of that blow. Okay. Let's let's move on. If you remove that from the link, you can see an example list of emotes you could add. I see. If I just remove this, we get to see a bunch of emotes. This is top of what? Is this going to be top of all time here? Top. Yeesh. Okay, there's a lot. I don't know if. See, I feel like I'm entering a culture that I've just have I've not grasped. So I don't know what the significance of all these emotes are. I might go fresh. We might have to do fresh emotes. These wouldn't count for your own upload limit, I believe. Oh, so you can just add any, and then there's an upload limit. All right, here we go. Trending weekly. So, is it usually? Oh, pot friend. Is it usually like a channel that like a single channel that will spearhead these? Something like this. Is the underneath? Is that like a? Is that the artist? I've been part of this culture since 2014, and I've never recommended it. I honestly think there are way too many emotes nowadays. Yeah, I think we're gonna have to be pretty tight with these emotes. The name underneath is the uploader, I believe, which definitely might not be the artist. Could be wrong. Okay, I see. Yeah, unless I was blown away by something that I see here, you know. Is new going to be precarious waters? Do they how well do they judge these things or make sure? Like, I don't know. I should be a little concerned here. Is there any type of adjudication? Man, why is Pepe so popular? Wild West, baby. Search Hollow Knight. Oh, do we get Hollow Knight ones? Sherma? Oh my gosh. Yeah, we have to get Sherma Dink. This is just incredible stuff. Absolutely. Okay, Hollow Knight. What do we got? What do we got? Awu. Yeah, we need an Awu. I don't know about Pet the Grub. Who made the initial pet? What is going on here? I kind of like the this Fleawu more, the cutout version. Okay. This is pretty neat. Sherma Slam. All right, I'll do some. We got to get the mushroom. We got to get the mushroom flying away. What was the mushroom guy's name? Oh man, Silk Song. Mushroom. Is it just Mr. Mushroom? Mr. Mushroom? Yes. Mr. Mushroom. Is he on here? No. Why not? All right, we got to make Mr. Mushroom. Pepe became a Twitch icon. Yeah, I know. I understand that it became the Twitch icon like a while back, but like, how is it still that popular? Like, what is driving the Pepe hype? I assume it came from 4chan, right? Yeah, I'd imagine. I think that's right. I think it's kind of transferred here. Then it became its own thing. Mr. Usher. Okay. All right, what do we got? We have an hour, 20 minutes. Should we get into this stuff? Should we just dive in? What did I want to do tomorrow? I wanted to... Okay, a predictive social brain. Yeah, we got to do it. So... yeah, we got to be productive. Okay, executive summary here. The cognitive architecture of the human brain functions not as a series of isolated circuits, but as a highly integrated neural economy where the allocation of resources, attention, focus, and motivation is governed by a complex interplay of neuromodulators, hormones, and metabolic substrates. This report provides an exhaustive analysis of the biochemical interactions that drive this economy. So, Lisa Feldman Barrett always talks about this stuff as body budgeting, and that obviously maps onto this idea of homeostasis or allostasis, where you can imagine that everyone's kind of coordinating to make sure things get done. You know, you could personify parts of the brain and say that everyone's in a dialogue to make sure that we don't die. Okay. Moves beyond the simplistic attribution of function to single molecules, for example, dopamine as the pleasure molecule, to explore the nuanced, often antagonistic and synergistic relationships that define mental states. Central to this analysis is the arousal attention action cascade. The research indicates that the locus coeruleus, I have to figure out the name of this. Pronounce. Whoa, it's a ceruleus? Oh my gosh, I would not have known that. Ceruleus.
Ceruleus.
Ceruleus. Wow, that's a. I've been saying this wrong for a long time. Twitch culture has this strange sociological foundation which ought to be studied, actually, where the users from... I'm sure it is being studied. I imagine people are working on books about it. Where the users from way back in the day still remember all the emotes and drama and carry the emote scene. I sadly don't remember the Justin TV stuff, but I imagine it's fascinating. Streamers such as Kai Cenat are actually like the equivalent of a corporation taking over some niche hobby. Like what happened with... Magic the Gathering? Interesting sociological phenomenon. Yeah. Now, granted, like it's a lot of streamers are really popular, and the takeover probably isn't first happening with Kai Cenat, but it's probably happened over and over and over again, as a bunch of people are contributing to the scene. All right, research indicates that the locus coeruleus norepinephrine system acts as the primary arousal volume control, determining the intensity of consciousness. The system operates in precise temporal coordination with the cholinergic system, the cholinergic system, is this acetylcholine, which directs the spotlight of sensory selection. Once a target is selected, the dopaminergic system, projecting from the ventral tegmental area and substantia nigra, provides the vector of pursuit, encoding the incentive salience necessary to overcome friction. However, the sustainability of these high energy states is dictated by metabolic constraints. The astrocyte neural lactate shuttle emerges as a critical mechanism, fueling the high frequency gamma oscillations required for focus by converting glucose to lactate. Okay. This system is regulated by the stress hormone cortisol, which acts as a double-edged sword, mobilizing energy and synergizing with dopamine in the short term while causing excitotoxicity and receptor desensitization in the long term. Okay. Furthermore, this report examines the brakes of the system, serotonin and adenosine. Serotonin functions antagonistically to dopamine in the nucleus accumbens, converting the drive of wanting into the quiescence of satiety. Adenosine accumulates as a metabolic byproduct, creating sleep pressure that eventually forces the system offline for recovery. By synthesizing data from receptor dynamics, neural circuit tracing, and behavioral protocols such as ultradian rhythms and non-sleep deep rest, this is the Huberman stuff, this document offers a comprehensive blueprint of the physiological machinery underlying human achievement. Whew. Okay. Substantia. Huh? What is good, Jago? Post-COVID was when Twitch went mainstream. I didn't understand any of that paragraph. Yeah, these paragraphs are rough. I need like a separate Gemini ready to go while I read that. I could also do this offline and spare everyone the difficulty here. That being said, I might stream for like 20 to 30 more minutes, and I think I'm just gonna throw my head at this wall. Make something productive out of it. But if it gets too rough, then maybe we just chill. I'm not sure. Translate this into English. All right, the initiation of any cognitive endeavor begins with a shift in the global state of the brain. Before specific information can be processed, the cortex must be woken up and primed for input. This primordial function is the domain of the locus ceruleus, a small bilateral nucleus in the brainstem that serves as the primary source of norepinephrine for the entire central nervous system. Okay, first question to be had. Does the locus ceruleus actually release norepinephrine? Or is it simply the main catalyst for this release? Where is the actual release happening? Explain like I'm 5. All right, the norepinephrine system does not merely regulate wakefulness. It modulates the signal-to-noise ratio of neuronal processing, determining whether the brain is in a state of flexible scanning or focused engagement. Okay, the locus ceruleus actually releases norepinephrine. It is not merely a catalyst that signals another structure to do the work. It is the primary physical source of the norepinephrine found throughout your brain. So it's releasing this diffusely. So imagine it just kind of like releases this into a pool, like the pool of the brain. And, you know, this spreads out and it connects onto a bunch of different I don't know if this is just going to be onto neurons or the synapses themselves. I'm not sure with norepinephrine, but are you checking Gemini against itself? No, I'm just using Gemini as a extra tool, like as a complement to itself. Because when you make a I don't know, when you make a deep research thing like this, it's very inconvenient to have to like jump back and jump forward to like the output that it has for this research. So I can just ask it questions and let it ride over here while the left is what we're going to be reading statically. Okay. The LC is the factory and the distributor. Wow. The neurons located inside the locus ceruleus contain the specific enzymes like dopamine beta hydroxylase required to convert dopamine into norepinephrine. Whoa! We're getting norepinephrine from dopamine? These LC neurons have incredibly long axons that project to almost every part of the brain. When an LC neuron fires, it sends an electrical signal down these lines, causing the physical release of norepinephrine molecules at the nerve terminals in those distant regions. Okay, I take it back. It's not just releasing it at like some single location and it's propagating. It's actually sending signals that are releasing it at these peripheral locations. Is the release via a synapse, overloading and diffusing there, or is there some other mechanism on the axon that diffuses the oh my gosh, norepinephrine neuromodulators. Okay. So it's the synthesis, it's the storage at its nerve terminals, and it does release into the brain. It's not the catalyst. A catalyst facilitates a reaction without being consumed. So who is the catalyst? Oh, it doesn't tell. Okay, that's fine. You're correct to suspect that overloading a synapse is not the primary mechanism. The locus ceruleus uses a specialized method called volume transmission. While most neurons communicate like a localized telephone call, one wire to one ear, it's actually usually like one wire to 1,000 ears. The locus ceruleus acts more like a radio tower or a sprinkler system. The axon are not of the locus ceruleus are not smooth wires that only release chemicals at the very tip. Instead, they are covered in thousands of tiny bulges called varicocytes. En passant release. What the heck? En passant is in here? As the electrical signal travels down the axon, it passes through these beads. At each bead, norepinephrine is released. En passant, in passing. That's what en passant means. Oh, that makes sense. No synaptic cleft. In many cases, these varicocytes. Okay. Varicocytes? Cities? I don't know. So yeah, it's releasing along these axons. The axons are these stringy things, these branches, let's just say, that are coming out of the coming off of the like the actual neuron's nucleus, so that the center mass of that nucleus, of the neuron. Okay. So that's fine. That's not that important, but I just needed to get that for myself. What's the next question? What do we need to ask? Okay, can you help me better understand the signal to noise ratio of neuronal processing that norepinephrine affects? This is a more functional view, I think. Okay, the anatomical reach of the LC is staggering. Despite containing a relatively small number of neurons, its axonal projections arborize, so like a tree, throughout the entire neuraxis. I've never heard of neuraxis being used. Innervating. Innervate. What do we got for innervate? Supplying with nerves. That's it. The cerebral cortex, hippocampus, thalamus, cerebellum, and spinal cord. This widespread connectivity allows the LC to act as a global broadcast system, synchronizing the activity of spatially distinct brain regions in response to salient environmental cues. Okay. So, synchronizing the activity of spatially so why would synchronizing the activity of spatially distinct brain regions result in signal to noise ratio? Is a concept borrowed from engineering to describe how clearly a neuron can detect a specific message amidst the constant background chatter of the brain. Okay, more signal because everyone's synchronized. You're not going to get a lot of noise that's going to make it more difficult for you to see what the signal is. So the signal is going to be much clearer because everyone's synchronized. That's what I'm guessing here. What does this mean in Fortnite terms? That's a good question. Understood. Got it. Got it. Norepinephrine is the brain's primary tool for optimizing this ratio. It does not just turn up the volume. It effectively acts like as a noise-canceling headphone that amplifies the voice you are trying to hear. So to understand signal-noise ratio, we first have to define what these terms mean for a neuron. Noise would be background static. Neurons are never truly silent. They fire randomly and spontaneously, even when nothing important happens. This is noise. If it is too loud, the brain can't tell the difference between a random spark and a real message. So this is like, you blow it up to a larger view where there's a bunch of neurons that are firing like this, and because they're not in sync in any way, then whatever abstract target or destination that we're looking at here is not going to be able to distinguish the signal that it's getting from all of these different neurons that are contributing to it. So if those other neurons were synchronized, then you would be able to see, that they're doing this type of signal. Okay. You want the signal to be high, you want the noise to be low. The signal is when a specific stimulus arrives, for example, seeing a predator, hearing your name. The neuron fires a strong coordinated burst of electricity. This is the signal. Okay, the dual action of norepinephrine. Norepinephrine improves SNR by attacking the problem from both ends simultaneously. This is often called gain modulation. Right, because I think when certain neurons fire more, or like when they're, not when they fire necessarily, but when they are, let's just say primed, they undergo this phase transition where they become much more excitable. I think that negatively affects neurons that are like around it in such a way where it inhibits other neurons. Now, when I say this, it's not like a single neuron's actually affecting the other ones. It's like more of a view of like the inputs that are coming into a neuron. It would have that type of relationship because of the inputs that are coming in, and the inputs that are coming in, would represent both excitatory signals that are helping this neuron out, and then it's coordinating that with the inhibitory signals that are going to the other neurons that are actually being inhibited. So it suppresses the noise, lowering the floor. When norepinephrine arrives in a cortical area, it slightly hyperpolarizes the resting neurons, making them more negative. Wow. Okay, so this is basically a multiplier. That's our first. Okay, that's our first Fortnite metaphor here. Norepinephrine is a multiplier. So the neurons that are getting the signaling that would otherwise be just like slightly more than the others, this is going to multiply that, and this is also going to be a multiplier on uh, neurons that are firing less than, we could say less than average, less than some normalization here. So it raises the bar for firing. Weak, random, or spontaneous electrical inputs are no longer strong enough to cross the threshold. The result is the background static fades, the hum of the room goes silent. It enhances the signal, raising the ceiling. Crucially, while it ignores weak inputs, it makes neurons hyper-responsive to strong inputs. Okay, okay. Imagine you are at a crowded party trying to listen to a friend. Low norepinephrine. The room is loud and your friend is whispering. You catch almost nothing. High norepinephrine. The magic of SNR. Everyone else in the room suddenly goes silent. So this isn't actually a great example because chances are your friend isn't louder than everyone else in the room. So this is a bad analogy. All right, the gain model. Why it doesn't amplify everything. You might wonder if NE is sprayed everywhere. Why doesn't it amplify the noise too? Okay, maybe it was a good analogy, and there's actually a bunch of noise around, but not affecting the. I don't know. Recent research proposes the gain model. Glutamate amplifies neuroadrenergic noradrenaline effects. This theory suggests that norepinephrine only amplifies neurons that are already excited by glutamate, the signal carrier. Ooh. High level of glutamate, the signal, create a hotspot. The interaction, when NE hits this hotspot, it acts differently than when it hits a resting area. It boosts the active hotspot while okay, so then this goes back to what I think what I said was then right, and this would be a bad analogy. Because you'd imagine that in a party, the reason why everyone's yelling is because there's actually a lot of excitatory transmission via glutamate across the entire party. This creates a sharp contrast, like increasing the contrast on a TV screen. The black gets blacker and the whites get brighter. Okay. Acting as a contrast agent. Okay. Would it be a fair metaphor to think of norepinephrine like a multiplier, according to some normalized level, such that even the quiet noise is negative. I'm glutamating. Oh my gosh. I'm glutamate. I don't even know what that would mean. Are we is more weight on the mating part of that or on the glutamate part? This is not just a fair metaphor, it is mathematically almost exactly how computational neuroscientists model the effect of norepinephrine. It's formally known as gain modulation. Okay. Defining zero. So this is the interesting thing though. To make your metaphor work, we have to define your normalized level, the 0 point. In a neuron, everything is about whether the voltage crosses a specific line, usually around negative 55 millivolts. Below the line is noise. The neuron stays silent. Above the line, signal. So output equals multiplier times input minus threshold. Okay, this is all good. This is all good. We've got our Fortnite version of norepinephrine now. Okay. How does norepinephrine actually affect neurons? Where are the receptors close to the nucleus or on the axon or dendrites? What's going on here? All right, we can continue over here though. Okay. So I think we figured this one out. We figured out the synchronizing the activity of spatially distinct brain regions in response to salient environmental cues. It's not like necessarily synchronizing. It's not doing anything that's like, I don't know, actually managing synchronicity of information in some like sense where it's like actually affecting. It's like not actually transferring information, but it's affecting how clear the information is in each of these subsystems that will now communicate globally, through the global network, affecting a more clear synchronized activity. So everyone else, every local system is getting less noise from other systems at the same time as their own system being more contrasted or clear. Manipulating the neuron's leakiness. Okay, the multiplier effect you intuitively described is physically achieved by manipulating the neuron's leakiness. To answer your specific question, receptors are located everywhere, dendrites, soma, and axon terminals, but they perform different jobs depending on where they sit. Plugging the holes. The mechanism, plugging the holes. The most common way norepinephrine acts as a multiplier is by closing potassium leak channels. Normally, a neuron is like a bucket with tiny holes in it. As it tries to build up enough electrical charge, water to fire, overflow, some charge constantly leaks out. This is the resting state, the norepinephrine solution. When norepinephrine hits an alpha-1 or beta receptor, it triggers an internal cascade that effectively plugs these leak channels. This is crazy. So it would make it so that less of the excitatory charge or just molecules are leaked out, causing them to be to contribute to stronger signals. Now, the same amount of input causes the bucket to fill up much faster. The neuron becomes hyperexcitable. So, okay. The big question I have here is, why doesn't the plugging up affect... No, it would. It would affect inhibitory signals as well, or molecules as well. And that's the point, I think. It's going to make it so that the inhibitory signals are more represented in the the actual logic of the neuron, whether the neuron's firing or not. Okay. So on the dendrites, the antennae, far from the nucleus, out on the branches where the neuron receives signals from others. What is going on here? Someone cutting into my building here? Signal amplification. By plugging leak channels here, norepinephrine ensures that a weak signal coming in from a neighbor doesn't fade away before it reaches the main body. It preserves the strength of the message. On the soma, the cell body near nucleus, right on the main housing. Okay. Function, lowering the threshold. This affects the trigger of the neuron. It modifies the voltage of the entire cell body, bringing it slightly closer to the firing line. Man, so norepinephrine really does work on the entire thing. While the receptor is on the surface, the chemical signal it creates does travel into the nucleus to change gene expression. This is how a stressful event today can create a long-term memory that lasts for years. Whoa. Jeez. And then on axon terminals, the brake. The function is the brake. This is unique. These receptors detect if too much norepinephrine is being released. If they detect high levels, they shut down the release valve immediately to prevent a panic attack or seizure. Whoa. Okay. Alpha versus beta. I'm glutamating an alpha receptor. Have you been washing your floor? Oh, is that what it is? Oh, my mop is there yet. Okay, I was thinking that you were saying that that was the sound, because I don't know if you've used this type of mop before, but you know, you wet the mop, and then you like put it into this spinny thing, and then you have to pound your foot on it to have it spin and get water off. But yeah, I did start a mopping a mopping process, and and I stopped halfway through, which is why it's just sitting there. I know that's actually a little tacky, but I still have to mop this room. I got one of those too. Yeah, pretty dope. Yeah, I'm a fan. So I'm not sure if the neighbor here is installing something or mopping, but very cool description of the mopping process. Thank you very much. Trying to just get it in a Fortnite level as well. Okay. The firing pattern of LC neurons are not uniform. They exhibit two distinct modes that correlate with opposing behavior states, tonic and phasic. Tonic firing, the baseline of alertness. Tonic firing refers to the sustained baseline rate of discharge of LC neurons. This rate sets the general level of arousal and determines the brain's receptivity to input. So, okay, low tonic activity associated with drowsiness, sleep, and inattention. In this state, the brain is unresponsive to external stimuli, and the signal-to-noise ratio in sensory cortices is low. So, what is this? Low tonic activity. This just means what? It's not firing much? To the sustained baseline rate of discharge. Just the general level of arousal and determines the brain receptivity. In this state, the brain is unresponsive to, okay. Moderate tonic activity. This is the optimal state for task management. It promotes an alert, flexible mindset where the organism is responsive to relevant stimuli, but not overwhelmed by background noise. And then high tonic activity, often induced by acute stress or anxiety. High tonic firing leads to a state of hyperarousal and distractibility. The gain on all sensory inputs is turned up, causing the subject to scan the environment erratically, the scanning mode, rather than focusing on a specific task. So yeah, let's just say the neighbor right now is like, let's just say they're drilling holes in the floor, and they just drilled like essentially like a square, and then the square falls through the floor. My reaction to that is going to be one of this high tonic activity where it's going to ramp up the release of norepinephrine. This is going to affect a lot of different parts of my brain, but it's going to synchronize my brain to one task, which is going to be figuring out what the hell just happened here. A pentagram, perhaps. That would be a little cooler, but it might be harder to repair. Okay, so this is the tonic firing. But then what is phasic firing? The interrupt signal. Superimposed on the tonic baseline are phasic bursts, rapid, transient increases in firing rate that occur in response to behaviorally significant stimuli. Okay, so maybe it would be like phasic firing, then high tonic activity. That might be the key here. The high tonic activity is probably the activity that like comes right after significant phasic firing. Phasic activation is believed to act as a network reset or internal interrupt signal. When a salient cue is detected, a phasic burst of norepinephrine is released, momentarily suppressing ongoing neural activity and facilitating a rapid reorganization of neural networks to process the new information. This mechanism is crucial for attentional set shifting, allowing the brain to disengage from a current task and reorient towards a new, more relevant stimulus. Okay, two questions here. How long does the phasic interrupt signal usually last? Are we talking hundreds of milliseconds, or are we talking seconds? Then is it is it usually the case that phasic firing is followed by heightened tonic activity, followed by heightened persistent tonic activity? What are we at? We're at 155. Maybe we'll leave it here, and then we'll continue after we finish our reading tomorrow, which should be once again quite fun. Yeah, because Lisa Feldman Barrett is actually pretty accessible in the way that she writes, which is cool. All this stuff is just what boomers have been saying, parsed into scientific language. What have boomers been saying? Are we talking about Jordan Peterson now? This is what Jordan Peterson's been saying. All right, the phasic interrupt signal is extremely fast. We are definitely talking about hundreds of milliseconds, not seconds. Furthermore, your intuition about what follows is actually the opposite of what usually happens in a healthy, focused brain. Okay. How long does the interrupt last? The entire phasic event from the moment the neurons fire to the moment they reset takes about half a second. When the locus ceruleus detects a salient event like a glass breaking or a sudden red light, it fires a tight burst of 2 to 3 electrical spikes. This happens very fast. The silence, immediately after the firing, the LC neurons completely shut down. This is called auto-inhibition. All right, why this matters. The specific timing creates a punctuation mark in your brain activity. It bursts to say change now and then goes silent to clear the channel for new input. This is generally, this is a common misconception. In an optimal state, phasic firing is not followed by a long period of high tonic activity. In fact, high tonic activity kills phasic firing. The two modes are often mutually exclusive. Okay. You only get good phasic interrupts when tonic levels are moderate. Oh, okay, so when you're drowsy, phasic capabilities weak, none. When you're stressed, the phasic capability is suppressed. Distractible, scanning everything, unable to focus on one thing. I see. So it would be like a moderate. All right. Why phasic doesn't usually trigger tonic? If every phasic burst triggered a persistent high tonic state, you would spiral into a panic attack within minutes of waking up. You want the LC to fire a phasic burst, allow you to switch attention, and then return to the moderate baseline. This keeps you in the zone. Exception, stress. If the phasic event is traumatic or highly stressful, for example, a loud explosion rather than a dropped pen, right? I'm talking about when the ceiling breaks. Then it can trigger a mode switch to high tonic activity, but this is a fight or flight state, not a focus state. Okay, that's what I was getting at. I think the takeaway here is that a lot of the time there's these phasic signals, these really short signals that are used to get your attention, but not in a very salient, like crazy situation like the one I brought up. It would be like a when you're driving and someone honks their horn, and because you're focused, that honk is going to get your attention, but then you can continue going on about your day, especially once you've figured out where that came from or what just happened. Okay, I think we call it there. Oh man, we still have so much about this. All right, let's call it though. Too much for my brain right now. What do we need? We can keep that. We probably don't need this. Probably don't need this. All right, let's call it there. Thank you all for chilling. I will try to remember to do the 7TV thing. Hopefully tomorrow, maybe the next day. We'll see. But yeah, back again tomorrow. Have a good rest of the day.